Good morning. This class we discuss some important compounds of phenol. First one is phenolphthalein. Phenolphthalein is very familiar to you because in our acid-base titration we use phenolphthalein as an indicator, and this class we are discussing the preparation of phenolphthalein. Phenolphthalein is prepared by the reaction of phenol with phthalic anhydride in the ratio 2:1 in the presence of concentrated H2SO4. So phenolphthalein is prepared by the reaction between 2 moles of phenol and 1 mole of phthalic anhydride. 2 moles of phenol and 1 mole of phthalic anhydride in the presence of concentrated H2SO4. So look at it here, phenolphthalein is prepared by the reaction between 2 moles of phenol, that means 2 moles of phenol and 1 mole of phthalic anhydride. How will you write phthalic anhydride? Look at it here, here it is C double bond O, and here also C double bond O, and here it is O. This is phthalic anhydride, this is phenol, and phthalic anhydride in the ratio 2:1 we get in the presence of concentrated H2SO4 we get phenolphthalein, okay, phenolphthalein. So look at it here, how the reaction is occurring. So this is phenol with phthalic anhydride, okay, in the ratio 2:1. So once again I repeat, phenolphthalein is prepared by the reaction between phenol and phthalic anhydride in the ratio 2:1 in the presence of concentrated H2SO4. So look at here, 2 moles of phenol and 1 mole of phthalic anhydride. Look at the structure of phthalic anhydride, benzene ring, C double bond O, O, C double bond O, that is phthalic anhydride. Now 2 moles of phenol. So look at it here, I am writing this is phenol, okay, phenol. I am showing the OH group here, and this is phenol, and at the para position this hydrogen you write like this. Okay, this is the first mole of phenol, and the second molecule, again you are writing the second molecule like this. Okay, here it is OH, okay, this is phenol, and at the para position, okay, write the hydrogen like this. Okay, write the hydrogen like this. Okay, clear? This is first molecule and second molecule, the phenol, and now you are writing the phthalic anhydride. How do you write phthalic anhydride? Look at it here, C. Here it is C double bond O, here also C double bond O, and here it is O. This is phthalic anhydride. Now in presence of concentrated H2SO4, what will happen? Look at it here. Concentrated H2SO4 is a dehydrating agent. So what will happen? Here it is hydrogen. Here is also hydrogen, okay, and here you can see that there is oxygen, and what will be eliminated? H2O. H2O will be eliminated. Once I am showing, okay, here you can see that, okay, here is your hydrogen. This is the hydrogen of first phenol molecule, this is hydrogen of the second phenol molecule, and here you can see that this double bond O oxygen, that means this 2 hydrogen atom and this oxygen atom will be eliminated as water molecule, so minus H2O. So and after that what will happen? The one of the double bonds, okay, this bond, one of the double bond, this will join with this phenol molecule, and this bond is joining with this phenol molecule. So what we get? We get a structure like this. Look at it here, okay, we get a structure like this. Okay, here it is OH, and second molecule here is OH, and our phthalic anhydride is, I am writing like this. Okay, here it is phthalic anhydride C, and here it is C double bond O. Of course, here it is our oxygen. Then what is happening? One of the double bond, this is joining with so here is a bond. Okay, so one bond is joining with this phenol molecule, and the other bond is joining with this phenol molecule. Clear? And this is what is the structure of phthalic and phenolphthalein. This is phenolphthalein. Okay. Okay, phenolphthalein. I think it is clear to you. This bond is joining with this para position of this phenol molecule, and this bond is joining with this one. Okay, this is the structure of phenolphthalein. Clear? Okay, look at here. So water molecule will be eliminated. Okay. Now, uses of phenolphthalein. Uses of phenolphthalein. First use is, as you know, what is that? First use is phenolphthalein is used as an acid-base indicator. It is used as an acid-base indicator, that you are using in the laboratory. Acid-base indicator. Second one, it's a component of a universal indicator. It is a component of one of the components of a universal indicator. Okay, and the next one is third one is it is used to trap corrupted officials. That means what do you mean by corrupted officials? So the officials, those who are asking bribe from common people, they are known as corrupted officials. So what we do, we are applying phenolphthalein powder. Phenolphthalein exists as a solid colorless powder, or you can say white powder. This phenolphthalein powder is applying on marked notes, currencies. We are applying that phenolphthalein powder on marked currencies, and the official who is receiving this notes as the bribe. And what will happen if we wash their hands with a dilute solution of alkali? What will happen? Pink color will be developed. That means from that it is very clear this official is received a bribe from common people or a bribe from somebody else. Okay, this way we are using phenolphthalein to trap corrupted officials. I think it is clear to you. So what do you mean by that? The official, those who are receiving the currencies with this applied phenolphthalein powder, what will happen when we wash their hands with dilute solution of alkali, will develop a pink color. So in this way we can trap corrupted officials. So these are the main use of phenolphthalein. Okay, first one is acid-base indicator. Second one, it's a component of what is that? Universal indicator. Third one is in order to trap corrupted officials. Trap corrupted officials. Okay. Okay, I think it is clear to you. Uses of phenolphthalein. Next is color change in phenolphthalein. Okay, the color change in phenolphthalein. That means you know that phenolphthalein, when we use phenolphthalein as acid-base indicator, we know that phenolphthalein is pink in color in alkaline medium, and it is colorless in acidic medium. That means, remember, so this is you are doing titration. So we know that usually what do? We are pipetting 20 ml of alkali into a conical flask. This usually we are taking, this is the reaction, we are taking 20 ml of a base, NaOH or KOH into a conical flask. To this conical flask, what we are adding? We are adding phenolphthalein, then it will change into pink color. Okay, phenolphthalein, that means this is basic medium. In basic medium, what is that? The phenolphthalein is pink in color. Okay, this is very known to you because when you are adding, we are taking 20 ml of alkali in a conical flask and we are adding 2-3 drops of phenolphthalein, immediately it is developing a pink color. After that, what we are doing from the burette, what we do? Okay, from the burette, what is that? We are adding acid. Okay, okay. When we add acid, what we can say that at end point, what will happen? This pink color will change into colorless. What do you mean by end point? The basic medium is just changing to acid medium. Okay, that is what is called the end point. So when we add acid from the burette, what will happen? At end point, the pink color is changing to colorless. Pink. That means so the pink color disappears. What do you mean by that? that the basic medium is just changed to the acid medium. That means in acid medium, phenolphthalein is colorless in acidic medium. Okay, in acidic medium, that you know. So what is the chemistry behind this color change of phenolphthalein with the change in pH? So once again, repeating, what is our heading? Color change of phenolphthalein with pH. Color change of phenolphthalein. Okay, color change of phenolphthalein. Okay, color change of phenolphthalein. So keep it in mind, in this class we are just giving an introduction of the color change of phenolphthalein. So keep it in mind, phenolphthalein is pink in color in basic medium and is colorless in acidic medium. Okay, that only you keep it in mind, and we will continue in the next class. Thank you.